Hello, this is Satbir. The topic of our discussion in this video tutorial is domain and range of a function. What is the domain and range of a function? In our previous video, we learned the notation of the function. So in function, basically, we have three entities, the x, which is an independent variable, the y, which is a dependent variable, and then there is a relation between these x and y, which we call the function. So when we talk about a function, there is always a three things. One is the independent variable, and one is the dependent variable, and then there is a one rule which say that each element of the independent variable has only a unique output of the dependent variable. So what is the domain? Domain is actually the values of the independent variable. So all the values, all the valid values of independent variable are called domain. So this is a domain. Means when you plug any values from this domain set into the function, you get a valid output. And that what is denoted by y. And now what is the range? Range is the values of all the values of dependent variable. All the values of dependent variable. That is called the domain, the range. So domain is the values of the independent variable and domain is the values of the dependent variable. So range and domain are connected because first we have to find the domain and then we can find the range, because in order to find the range, we have to insert all values from the domain to find the range. Let's take some example. So my first example of the function is f of x is equal to x minus 2 divided by 7x plus 10. So here this is a independent variable x, and this is also the input of the function, and this is the output. So again, you can think that the input is a domain and the output is range. So this is gonna be range. Now, as you can see that if you put some input to this variable x, then you get a certain output. So initially we can think of the domain is the set of all real number, because if you plug any real number, you will get some sort of output. But there is a one real number, which is a problem. And this real number is if I plug 10 over 7, negative 10 over 7. This is a special real number, which is a great problem for us. You will see in a minute. So if I plug 10 over 7 minus 2, whole thing is divided by 7. Now I will insert minus 10 over 7 plus. If you simplify the top, you get minus 24 over 7. And if you simplify the bottom, 7 gonna cancel out and you're gonna get negative 10 plus 10, which is a 0. So now we have a situation, we have a top is a number and bottom is a 0, so which is a no. So this is not an output. Basically, this is not a valid number. This is not a number. So since this number does not give us any output, so we will say that this is not a input. This should not be the part of the input. So we will say, this is the notation for the domain. We will say the domain of the function is all real number. Any number you can think of is in the domain, but this number, which is a negative 10 over 7, is not in the domain. So this is the one way. This is a minus at, if you say all real number minus this number. Or there is another way to write this notation is in interval form. You say minus infinity to negative 10 over 7, and then you use this cup, which is also called a union symbol, and minus 10 over 7 to plus infinity. So this is the domain of the function. Now you might have one question: how I come up with this number? How I know that this is the number which is going to be not in the domain? So how I come up, basically I look into the function. My function was a rational. So if I take my rational function denominator and set is equal to 0, whatever I value get of the x variable, that value will be a problematic when you will plug that into the function. So as you can see, this value is, I can add negative 10 on both sides and then divide by 7 on both sides. So this value bring the 0 in the denominator. So I have to remove that value from the domain of the function. Okay, let's do one more problem. This time our function is a square root function. It's not a rational function. This time it's a square root function. And we need to understand one thing about the square root symbol, that you cannot insert negative values in the square root. So that is a wrong. So having a negative number inside the square root will be a problem. So now what will be in the domain? So domain will consist all the real number as long as inside of this square root stay positive. That is our goal, you know. So we want the all real number, but we also want, when we plug all these real number here, this quantity inside of the square root stay positive. How we can achieve this? So there is a one mathematical way in steps by step. If I take this number, what is inside of the square root, and set is equal to 0, that will give me x is equal to minus 6 over 5. And this is a step number 1. In step number 2, what I will do the line test. So here is a number minus 6 over 5, you know, and then I will choose the point which is on the right, and then I will choose a point which is on the left. Minus 6 over 5 is around 1, so then I will choose negative 2 here, and 0 is here. So now if I plug this into this equation, 5 plus 6, if I plug 0 in here, I get a positive here. If I plug 0, I get a 6, which is a positive number. If I plug negative 2 in 5x plus 6 expression, I get a negative number. That's all I need. So what this means is, it means if I am on the right side of minus 6 over 5, this expression is always positive. And on the left side of minus 6 over 5, this expression is always negative. So therefore, my domain of the function, because I only want to choose the positive number inside the square root, therefore the domain of my function is minus 6 over 5 to plus infinity. Let's do one problem really quickly. This time we have the expression f of x is equal to square root of x square minus 5x plus 2. All we want is to find all the value of x when the square root, the inside of the square root expression is positive. So what I will do is basically I will set this expression is equal to 0, and then I will calculate the value of x. This time I have two value of the x. Last time I have only one x there. So I will plot that on the line. Here I plot these two value. Then I will pick a testing point one on the left, one on the right, and then I plug this testing point into this function, x square minus 5x plus 6. And then I get this positive. If I pick any values on this side, this expression is positive. If I pick a value between 2 and 3, this is gonna be a negative. And if I pick any value which is a more than 3, is going to be a positive. So we only gonna pick a positive interval. So minus infinity to 2 is a positive and 3 to infinity is a positive. Therefore, the domain of this function is this 2 interval, which is a united by or combined by this union symbol. Here I have one quiz problem for you to practice. Please pause the video for 1 and 2 minutes and work on this problem. Here is another problem which you can also practice. Please pause the video for 1 and 2 minutes and work on this problem as well. This is also the end of this video. Thank you very much for watching. I will see you in the next video. Bye for now.